AS-Level Circular Measure Exam Preparation Questions Part 3. Let's continue with another example. In the diagram, OAB is a sector of a circle with center O and radius 2r. So basically, let's just say this is 2r, this is 2r. Okay. And angle AOB, it's 1 over 6 pi radians. The point C is the midpoint of OA, so it divides it into R and R. Okay. Show that the exact length of BC, so I'm in this triangle. So the exact length, and it's in terms of R. Okay, and pi. So basically, yes, R, and it's not a pi, it's just in terms of R. So basically, I'm going to just, don't get an answer, I'm just going to keep it in terms of R. But always, if you see 1 over 6 pi or 1 over 3 pi, always think of your special triangles. So use the cosine rule. So I'm going to say, okay, so BC squared is equal to this side squared, let me just highlight, this side squared plus this side squared minus this times this cos 1 over 6 pi. And as I said, draw your triangle. It was an equilateral triangle. So it was 2, 2, 2, but I'm only working with half. So this is 1. Remember, this is 60 and this is 30. And I remember it like this. If it's 60, then it's pi over 3. And if it's 30, it's not taking, then it's pi over 6. So I can basically go and I can substitute in this pi over 6. If I see, so if I'm saying cos, it's adjacent over hypotenuse, and I just substitute that. So please remember, when you see this angle, 1 over 6 pi or 1 over 3 pi, that you go to your special triangles. Okay, now I'm just going to simplify. So this plus this is 5r squared. If I multiply this, 4r squared. And now if I put this over 1, I can say 4 divided by 2, and this is where I got the 2. Okay, and then I just take out r squared as a common factor. But now, remember that was BC squared, so I take the square root. Now, this is why I did in my book search, in the beginning of the book, because you need to know the basics of search, although it's not specifically in the syllabus. So I have to take, I can take the, if it's multiply, it's almost like if you have, say, 4 times 9, that is equal to the square root of 4, and the square root of 9, because that would be 36, but this would be 2 times 3, which would be 6 and 6. Can you see that? And that is the principle I use there. So basically I take, and this one go out, and this one just stay in the bracket. And that's exactly what they wanted me to get. And then find the exact perimeter of the shaded region. So the arc of AB, so it's going to be R times the angle. So it's, don't forget, it's 2r. In the place of r, you put 2r, 1 over 6 pi. Okay, so the total shaded region is going to be, okay, but now it's going to be, let's just say, find the exact perimeter of the shaded region. So I'm already having BC, and I have CA. Can I rather just use another color? CA. And I find that AB. Okay, so I find the AB. There is the AB. Do you see? And then, so AC was that R. And then that BC was the one they gave me. Okay, and then I'm basically just that one in terms of that one. So basically, it's just 2r over 6 pi. And you leave it like this. It's an expression. Okay. And then find the exact area of the shaded region. Okay. It's actually good if they set in terms of r or pi. But if they don't say it and you don't have values, you just continue doing it. So the shaded area is the area of the sector. Okay. So it's the whole area the area of the sector, do you agree, minus the area of the triangle. Okay, and then you sit with it. So the area of the sector, it's a half, and then it's 2r, and you have that angle, and you can work it out. The area of the triangle, so don't forget, now you will use the sine rule, so it's half r 2r sine, okay? And then don't forget also that sin, this is what I got there, but if I say sin pi over 6, go back to this triangle, sin, it's opposite over hypotenuse, and that's a half. So I can substitute a half in there. And then basically, I just want to make it a bit bigger so that you can also see it better on the video. Okay, so basically, I'm just going to simplify this. It's going to be 4 over 12, which is a third. And then I'm just getting pi r squared. And that was just, oh, I shouldn't clean this. And this was just a half r squared. And you can take it out, and it's in terms of pi. So I think if they phrase it better, to say it's not the exact, it's in terms of pi. But it will be exact. If you have the value of r, then it will be the exact, but it's in terms of pi and r. Okay, now this makes it always for me a level 3 question, because it's not values, it's in terms of r and pi. That can be sometimes more challenging. Okay, and this is why I gave you also a little bit in terms of this values. Okay, and this is the exercise. So again, I want you to do the same. I want you to stop the video. I want you to try number 1 and then check and then go on with the video and assist. But first, always try to do it on your own, okay? Because part of, if you struggle a little bit with it, you will understand the video better, okay? So let's start with number 1. So a sector of a circle, with radius r, okay, has an area of A, okay. Express the perimeter of the sector in terms of R and A. And this is for me nice if they phrase the question like this. But let's start. We have the area of a sector. Write down the formula. You know the formula. I think it's on the formula page also. So it's half r squared pi. Okay. So now, if you want, I want theta. So make that the subject of the formula. So it will be A over a half r squared, and that's pi. Okay, I can simplify. I prefer to simplify this better. Okay, I'm going to do it long, sorry. So if I put this, it's going to be r squared over 2. As I said, sorry, I'm a bit long, but I want you to really follow what I'm doing. The reciprocal, so 2 over r squared. So this is going to be 2a. It's just better working 2a over r squared. That's what I want you to see is theta. Okay. And now I want the perimeter. So what is the perimeter? The perimeter, but don't forget, the sector, can I just show you? Say, for example, you must not forget this part. Okay. I'm first going to find this part. This part. Oh, sorry. Okay, this part. Okay, but don't forget the perimeter will also be this plus this. Okay, but let's first find the perimeter, and let's write it nice. Perimeter of the sector. Let's first find perimeter. Okay, so let's make this is r, and I'm finding that one. So it's 2r plus r theta. So basically, it's that 2r plus r, and now don't forget you have theta. So it's 2a over r squared. And that is going to be 2r. And don't forget that one of your r's is cancelling out. So plus 2a over r. And that is your final answer. That in terms of, so it's a bit challenging. So be careful for this kind of sums. Okay. Okay, I think, because I don't want the videos to be too long, I think I'm going to stop now, and I will just continue with number 2 and 3 in the next video. A final note. Most of the videos on this channel feature examples from the Y equals mx+c to Success Mathematics books. Try your best to purchase your own hard copy from one of the following bookshops. This will enable you to highlight and make personal notes in your own textbook. And remember, the only way to learn mathematics is to do mathematics. Best of luck.